All right, Mr. Claxton's algebra students, we're going to go ahead and explain here the percent change, or percent of change. I'm going to try to give you some hints. The goals here are that you can use those, the ratios to find percent change, and for you to use shortcuts as well to solve problems involving percent change. First thing that I want to start out with here, just looking at what percent is. If you can make statements like 10% of 162 is, and then what would that mean that we need to do? We need to convert the percent to a decimal, move the decimal place 2 to the left, and then multiply that decimal by 162. So that's how we would do it on a calculator. Now, when we're dealing with 10%, we can just move the decimal one place to the left of whatever we're multiplying by, and we would get 16.2. 20% of 162, we would convert the 20% to a decimal, move the decimal 2 to the left, the decimal point rather, multiply 0.2 times 162, we would get 32.4. Now you probably figured it out. If we just double 16.2, we get 32.4. So if you're looking for 20, if you can find 10%, all you got to do is multiply by 2 to find 20%. So there's a little shortcut. Now your book starts out with some problems where it gives you the original. You could think of that as the original amount or original cost if you want to. Those problems are a little later. Just the original amount, and then they give you the final amount. And you have to determine whether or not it was a decrease or an increase. So if the original amount's 20, final amount's 23, that is going to be an increase. And it wanted us to find the percent change. I know a lot of us are familiar with is over of equals percent over 100. And here, just so you can apply some common vocabulary, the base would be of, and then that percent right there would be rate. We refer to that as rate. So is over of equals percent over 100. Looking at some of the examples from the book, what they had to do in order to determine the change is they had to take that new value and subtract the original. So that's how they got their values up here. For example, is or 3, which would be the change. And then the original amount was 20. So what they had to do there, they had to take 23 minus 20. So notice how they have 23 minus the original amount of 20, which I tried to make blue. When it's negative, that would indicate a percent decrease. Now, to me, it's a lot easier just to look at the problem, see the original is 25, the final 17. We know this is going to be a decrease. And so I would declare this very early to be a decrease. Sometimes negatives can get confusing. And I do not want you to think that it's okay to have a negative percent. That is not okay. If we are figuring out a percentage, that percentage will be expressed as a positive. We will say a 32% decrease, though. So we do not want to express percentages as negatives. We would just say a 32% decrease. Now, how do they do that? They put -8 over 25 is equal to R over 100 to figure out that rate. Once they figure out that the rate is -32, they call it a 32% decrease. Notice here that the rate is already, it does not need to be converted. Whatever number you get for R is going to be the percentage. So that is an important point to make note of. Looking at some example problems here, you'll notice what I did. If you want to pause and look at these, I'm not going to take a lot of time to explain them because my video will not upload. But if you look at this, we took in 1C the new amount minus the original amount. So we know this is an increase problem. We had an increase of 16 is what I would say. And that 16 is going to go in the is space down here. We know our original amount was 24. So 16 is to 24, just as R is to 100. We use the cross product, 24 times R equals 16 times 100. Divide each side by 24 to get that rate of increase. Looking over here at example 1D, we take, well, we know it's going to be a decrease. Our original was 500. We went down to 131. So we know it's a decrease. 131 minus 500 would give us negative 369. So negative 369, that's what we're trying to figure out there. What would that be as a percent decrease? So we write that as negative 369 is to 500, just as R is to 100. Notice we use the cross product. In here, we know that R times 500 is just 500 R, if you're someone who starts with R there. Negative 369 times 100. Divide each side by 500. And we get negative 73.8. Now, I would not want to write negative 73.8%. That would be wrong. It would be a 73.8% decrease is how we would describe that. With the word problems, it does get a little bit tougher to figure out. And the way that the book uses here, it's not a terrible way to do it. We can talk about an easier method whenever I get back to class. So they just let F be that original amount. So they're letting F be the original amount because the original amount is unknown. So if you look here, the total number of passengers on a cruise ship increased 10% from 2007 to 2009. If there were 17.22 million, that's 17,220,000 passengers in 2009, how many were there in 2007? So this one's a little bit tougher because we're trying to figure out what the original amount was. So in order to do that, we would let F equal that original amount. And just so you know, the new minus the original, there's nothing different than what we did before with the new minus the original. That would be represented as 1,700 or no, 1,000, it'd be 17.22. So 17.22 minus F. So that's what we would get there. Now, what they did is they multiplied by 100. When they multiplied by 100, they got 1,722. So 17.22 minus F. And then when they multiplied it by 100, that moved the decimal 2 to the right. So there should be a decimal point right here. So you see, even the book makes mistakes. Even the book makes mistakes. We all make mistakes, right? If you look at that guided practice example, if you want to try this on your own, you could pause and try it on your own and then come back later to see if you got it right. But once again, we're trying to figure out what the original cost was. We saw a percent increase. We want to figure out what was that original cost. So we would need to represent that original cost as F. And we take 33,408 minus F, and that's going to represent